Hello, my name is Travis Fowler. I'm a student at the University of Texas at Dallas in the Arts and Technology program, and I'm here to talk to you today about Attractors and Rhino using its plugin Grasshopper. Now you might be asking, what is an attractor? An attractor is the geometry that influences surrounding objects' attributes. So it could change an object's size, its shape, its color, its rotation, pretty much anything that that object can do or be can be influenced by an attractor. An attractor operating on a single object can be quite dull, but as you'll see in this example, if the attractor is given many objects to influence, something that Grasshopper excels at, you can easily achieve intricate and interesting outcomes. So if you take a look right here, this is the point that we're going to be using as our attractor in this example. And here are some of the circles that we're going to be deforming. So as you move the point around, the attractor properties make the circles change direction and face that. So you can kind of see all of them point towards this point right here. We're going to step through this piece by piece so that we can get you introduced to attractors on a very simple level. Okay, so starting off with a blank Grasshopper file is really important. So let's run Grasshopper from a new Rhino document and look around. We're only going to be using the top view for right now, so let's go ahead and hop back over to Grasshopper and put in a hexagonal grid. Now this grid is going to allow us to find points that we can use later on to make some circles. And we're just setting up the parameters right now. Feel free to pause the video and follow along if need be. What we're doing is we're changing the size of the cell and the number of cells that each has. So right now I'm connecting the extent X and extent Y, and that's just meaning that there's going to be 10 in each of the direction, as you can see. And then the size slider right here is going to go into the S of the hexagonal grid. And there you go, you can see I'm going to scale it up. Let's just take it to 1. Alright, so now we're set up to start adding our attractor. Okay, so now that we got our grid all set up, we're going to move over into the Rhino window again and add a point. So type point in the command prompt, grab it, plop it down right there. This is just a normal point. As you can see, you move it around, nothing cool happens, just kind of hangs out. So now we're going to have to hold it in Grasshopper. It can't just float around in Rhino, it has to get in to do some damage. And so as you can see, it just says that there's no point set, so you're going to go to a set point and come over and pick it. There you go, it's red little X. If you click on it, it turns green, highlighting it. And there we go, we got a point set. The next step after you get your point set is to grab some circles. So let's grab the circle CNR component in Grasshopper, place that into our definition. CNR stands for center, normal, and radius. So every point on this grid is going to become a circle. And they're a little bit too big, and we want to have control over them. So we're going to go ahead and grab the size and throw that into the radius. And now we're going to move this over. It's going to be tidy a little bit. So here's this point that we have, but if we plug this directly into our normals, they all do the same thing, and that's not going to cut it. We want something cooler than that. So let's disconnect that really quick and move on. Okay, now that we have our circles made, let's use our attractor to make a difference. Now we're going to use the vector 2-point to make a vector out of the points from the grid and our attractor point. Now these vectors are going to serve as our normals. You can see over there our circle doesn't have one yet, so we're going to be plugging that in. Okay, so let's plug in our vector to the normal component of the circle. As you can see over here, something strange happened, so let's turn off the preview on this hexagonal grid so we can see a little bit clearly. It doesn't look like it's doing what we want it to, so let's fix that. So I backtracked a little bit. Let's just plug that vector back into the normal. Oop. All right, there we go. And as you can see, it still has that weird pattern going on. So let's move over to our perspective window to see what's going on. Zoom out a little bit. So it looks like all of them are just standing perfectly on their side, and that's what's making those lines appear from the top view. So what we should do is let's grab our point and move it up some and see how that changes our attractor. All right, so we got something a little bit closer, but it's still not right. The circles are a little bit big, they're overlapping, and we need to fix that now. To fix our sizing issue, we're going to grab the offset component. As you can see, some of this stuff is still a little bit overlapping, so grab that offset component. And Grasshopper is really friendly. lets you know that C connects to C, pretty straightforward. And then the second one here is called the distance. So let's turn off these previous circles and just look at our offset circles. You can see that they kind of got a little bit bigger than we want them to. So let's grab a number slider and see if we can adjust that to a more reasonable size. So I'm going to go from -10 to 10 in our distance. And I'm going to slide around. Oh, looks like it's kind of difficult to control. I'm going to go back in and readjust the parameters for this slider from -3 up to 3. Yeah. So now this number slider is much more fluid, gives you better increments, and I like that. I think that's going to do. All that's left is a couple of housekeeping things. I like to keep a nice tight definition, so I'm going to scooch everything in a little bit closer. It's really good to keep tight definitions because when they do get really big, they start to get a little bit out of hand if you're not organized, and it's always good to keep your workspace nice and tidy even if it is virtual. Yeah, this is a pretty simple attractor. I hope you have fun messing around with it. Try some other things out. I'm going to show you a curve as an attractor as a short demo. So here's that curve definition I was talking about. This uses a curve as an attractor running through that grid. You can kind of see all these circles are deflected towards that line. And everything's pretty similar to our last definition, a lot of the same components, except for we got some curve stuff going on here. And that just takes the closest point from the curve to our attractor and lets us use that as the point that we use to make a normal. So in addition to that deflection definition, I've also set up a size changing based on the distance to the curve. So let's turn off the deflection and turn on the preview on that size change. And as you can see, the closer you get to the curve, the smaller your circles are. I do annotate all my stuff just to keep it nice and tidy, as you can see. But let's combine them. So let's take the radius that we're grabbing from the size and turn it over to the same circle that we're manipulating with the normals. And we turn this on, you can see you get a combination of both of these effects along that curve. And if you grab some of the control points on the curve and start moving around, you can see the effect that it has. You can just go nuts with this and you can do whatever you want now that you know how to use attractors. You can use the product of your Grasshopper definitions in many different fashions, as part of an illustration, as input for a laser cutter, or even as the foundation for a 3D model to be printed. I hope you found this tutorial useful, and thanks for tuning in.